So welcome back, learners, to our LearnJet KCSE revision. I think we stopped at this point when we were talking about the reagent that is required in step 3. So down here you are also asked the reagent that is required in step 6. So look at step 6. You come back to your table here. I want you to look at step 6 very well. So I'm trying to enlarge this so that you can view our content very well. So if you come to step 6, in step 6, what is happening? Sodium is reacting with something and then you form sodium peroxide. You know, when sodium reacts with oxygen that is limited, you form sodium oxide. But when sodium reacts with oxygen that is excess, you form sodium peroxide. So you have to know that whatever is being added in step 6 is oxygen, and not just oxygen, it is excess oxygen. Because excess oxygen is the one that forms sodium peroxide. But if you add limited oxygen or an ordinary oxygen, you're going to form sodium oxide. So you have to know that whatever you require in step 6 is excess oxygen. Excess oxygen. So there you need excess oxygen. That is important. So I will also highlight this. Just going to highlight this in a red color also. So there you need excess oxygen. And then you're told, give the condition necessary for the reaction in step 5 to take place. Give the condition necessary for the reaction in step 5 to take place. So just look at step 5. Where's our step 5? Oxygen and copper to form substance U. What do you need? You know, when oxygen combines with copper, you form copper 2 oxide. And in this particular process, whatever you need is heat, because heat must be here for this reaction to take place. Copper and oxygen cannot react without the presence of heat. So whatever you need in step 5 for the reaction to take place, your answer there is going to be what? It's going to be heat. You have to note that. You need heat. Okay. And then now we go to question D. Write equations for the reactions in the following steps. Write equations for the reactions in the following steps. So I'm going to start with step 1. We're going to start by writing the equation in step 1. So look at step 1. In step 1, hydrogen peroxide is reacting in presence of, I told you, is manganese oxide, and then you form oxygen gas and water. So you're going to write that equation here, because in step 1, what is happening? We are having hydrogen peroxide, which is H2O2, H2O2. Remember, hydrogen peroxide is a liquid, so you have to note that. And it is reacting in presence. You know, it's reacting in presence. So here I'll have to insert an arrow. I'll come and insert my arrow here. This is my arrow. It is reacting in presence of manganese oxide. Remember, manganese oxide is MnO2. So it is reacting in presence of manganese oxide, and then you're going to form, in this process, you're going to form water and oxygen gas. Because you're going to form water, which is H2O. And remember, water is a liquid, so you must indicate there that water is a liquid. Then you are going to form it plus oxygen gas. Remember, oxygen gas is O2. Oxygen gas is O2. And remember, oxygen is also a gas. That must be well noted. This must be small. Oxygen gas. Then you ensure that the equation is balanced, because hydrogen in this side is 2, hydrogen on this side is 2, oxygen on this side is 2, oxygen on this side is 3. So what you'll do, you'll write here 2. Naona ukiandika hapa mbili, hydrogen hii side zinakuwa 4 na hydrogen hii side zinakuwa 2. So hapa pia lazima uweke 2. Okay? This side you must also write 2. So you're now seeing that hydrogen on this side is 4, hydrogen on this side is also 4. And then oxygen on this side are 2 plus 2, which is 4. Oxygen on this side are also 2 times 2, which is what? 4. So this is the equation that is going to take place. This is the equation that is expected from you from there. That is hydrogen peroxide in presence of manganese oxide, and then you form water and oxygen gas. So that is the correct answer for that particular question. When you come to step 2, you'll go back to the equation. Look at step 2. In step 2, oxygen, I told you, is reacting with something, and then you form sulfur oxide. And I told you the substance that is reacted in step 2 is sulfur. So oxygen is reacting with sulfur. So you'll come and write here. You'll start with sulfur reacting with oxygen. So take up a sulfur, and remember sulfur is a solid. So sulfur is a solid. So the status symbol must be noted. Sulfur is a solid. And this sulfur is reacting with oxygen. And remember, oxygen is a gas. Oxygen. And this oxygen nandikwanga O2. And it is a gas. It is a gas. And then you have to ensure that you are also indicating the arrow. How do you insert? You come to shapes. So this is where you indicate the arrow. So I'll just come and indicate my arrow here, this point. So I'm going to have sulfur plus oxygen, and then in this particular process, I'm going to be forming sulfur oxide. I'm going to form sulfur oxide. I'm going to form sulfur oxide. Sulfur oxide. That is SO2. 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 And remember, sulfur oxide is a gas. Okay? Sulfur oxide is a gas. And ensure that this equation is balanced. So sulfur on this side is 1, sulfur on this side is 1, oxygen on this side is 2, oxygen on this side is also 2. So our equation for this particular is balanced. So that's okay. That equation is balanced. So you get, remember, a well-written chemical equation must be well-written and must be well-balanced. We go to step 5. In step 5 is where now you are reacting oxygen and copper. When oxygen reacts with copper, you form copper 2 oxide. Okay? So at this step 5, you're going to have copper reacting with oxygen. Remember, copper is Cu. Copper is Cu. Copper is Cu. And this copper is a solid. Copper is a solid. So you have to indicate here that copper is usually a solid. And this copper is reacting with what? The copper is reacting with oxygen, which is O2. Copper is reacting with oxygen, which is O2. And this O2 is a gas. This O2 is a gas. And then in the process, you are forming copper 2 oxide. In the process, you are forming copper 2 oxide. So I'm still going to insert my arrow at this point. So I'm going to get copper 2 oxide. So I will indicate the arrow at this point. So I'm going to have copper 2 oxide at this point. Okay. So I'll just move here. This is where I'm going to form copper 2 oxide. This is where I'm going to form copper 2 oxide. Copper 2 oxide. And remember, copper 2 oxide is a solid. Copper 2 oxide is a solid. Okay. So this is our equation also for this particular what? This particular equation. So you can see that it has been well written and it is also well balanced. Okay. So when copper reacts with oxygen, you form copper 2 oxide. When copper reacts with oxygen, you form copper 2 oxide. That is important. So this one, these are things that you can just that is yes, okay. Now we come to question E, where you are now asked, state and explain the observations made in step 5. Look at step 5. In step 5, look at step 5. In step 5, you're having copper reacting with oxygen. And when copper reacts with oxygen, you form copper 2 oxide. Which observation are you going to make? The observation you're going to make is very simple. Remember, copper is a brown substance and oxygen is a colorless gas. So when copper reacts with oxygen, you form copper 2 oxide, which is black. So your answer will be brown copper metal changes to black copper 2 oxide. Write that. Write brown copper metal changes to black copper 2 oxide. Copper 2 oxide. You're noting that? So that means, you know, copper itself is usually brown, but when it combines with oxygen, it forms copper 2 oxide, which is usually black. So that also becomes your answer for this particular question. So up to there, learners, I hope you are learning something. And as we proceed, I'll still be doing more successive videos on this, and I hope you are learning something. Thank you.